Hey, what's going on, guys? It's Nate here back with the very first application showcase. In this video, I'll be taking an overview of the console universal calculator that we are about to release. By the time the video is up, it will be released. So anyways, this is going alongside patch 1, which we're updating all the graphics and just refreshing Tech Union for 2016 and making general improvements everywhere. Do expect patch 2 near the end of the summer, and if not, probably sometime in the fall. So anyways, now that that's over, I want to talk about this console universal calculator program I just made. So it's an exe file when you download it, so I'm going to go ahead and start the download, and then once that's finished, I will open it up and then we can take a look at it. Alright guys, it finished downloading, so let's go ahead and start it. So as you can see, it's an exe file. Go ahead and click it. Windows Smart Screen tells us that it's protected and we can't do it. So what we have to do is click run anyway. If you don't trust the program, there is another way to run it. You can go ahead and install all the Python files and go ahead and run it that way. But you have to install all the modules that go along with it. So if you don't trust me, do it that way, but this is the easy way of doing it. So run this program anyway, so that's what we're going to do. I'm running it on my computer, so you can see for yourself. Alright, so here it comes, right here. So let's go ahead and make this a bit more readable for us. So let's go ahead and change this, go to about 18 font size. Okay, maybe a bit more. Go 20. Alright, that's good. You can also do a bunch of things when you edit you can edit your command line. You can go up here, right click properties, change the font size. You can also change the colors of it. So I'm going to go ahead and do that real quick. So I'm going to go to the screen background, turn it into white, and the screen text I'll do this nice color of blue. There we go. Alright, let's make sure it's the blue I want. Yeah, that's good. Oh, whoops, I accidentally changed the background too. Alright, so here we are with the voice crack, sorry. The console universal calculator version 1.0.0. That A will be removed pretty soon, so don't worry about that once it's released. So Tech Union 2016, I did the programming for it, and Chase Glenn mainly did the testing. So anyways, as we can see from the start, we can look at the syntax rules, and it tells us how to do addition, subtraction, multiplication, division, and so on. And also gives us a bunch of notes and features about additional things we can do. So what I want to do is just take a look at a couple of these features. So I want to take a look at algebra first. That sounds pretty fun. Let's do a factorial of a very large number. So let's do like a factorial of, let's do say 80 factorial. Bam, instantly. So if we want to, let's do some primality testing too. So we can do some primality testing. We can go ahead and check and see if, and of course this will be composite since it ends in 8, but it takes a little bit of time for it to compute since it's such a large number. Hope I didn't freeze it actually. I'll give it about 6 seconds and then I'll pause the recording. 5, 4, 3, 2, 1. Alright, I'm gonna pause the recording and come back. Alright, sorry guys. It looks like I entered too big of a number, so let me just try that again real quick with something a bit more reasonable. Let's do like 100,000 or something. 52.9. Alright, bam. There we go. As the number goes larger for the primality test, it gets a lot more computationally expensive because you have to do I'll explain it. You can look at the algorithm for yourself in the source. Anyways, let's continue on. So another cool feature I want to show you guys is function calls. So let's go ahead and make a cubic function, and yeah, don't worry about all this. This is just pretty much telling you how you can what types of functions you can make. So anyway, just a bunch of instructions if you want to test stuff out. So our function is f of x equals x cubed, so let's go ahead and do a function call on that. Let's see what's, let's do 5 cubed. Yep. Alright, so, and with this we can also find the roots of the function, which is 0. We can find the y-intercept, which is also 0. We can factor it, and you can't factor it. And you can also expand the function. So let's go ahead and exit that, and let's try something else. So let's go take a look at the graphing module. So this is pretty much more instructions on what types of functions you can make. So let's go ahead and graph a function. Let's make a sine graph. So let's do trig functions dot sine, and the argument will be the variable x. So let's do 2 times. Let's just do regular x. So as you can see right here, it tells us how to write the sine function. Trig functions dot sine, and then the argument, which is the variable x. And we have to enter our domain. So let's do -5 to +5. And as you can see, it graphs the function. Alright, so let's go ahead and graph a different type of function real quick. Let's go ahead and graph I selected coordinates, so let's do that real quick. So another feature you can do, I'm sorry if I'm talking too fast, is you can use constants, and you can also write expressions. So if I want to have an x-coordinate with the value of Euler's number, you'd have to write math.e, and then the y-coordinate of a value of math.pi. As you can see, it's the x, we're on math.e, and for the y, we're on math.pi. Alright, let's go ahead and take a look at some computer science. If we want to do some base conversion, we can go ahead and do that. Let's go ahead and convert, let's do base n to base m. Let's do base 36, and let's do my username for Pokemon Go, Big Nate with a Q 777, and then convert it to base 10. And then that is the decimal value of my username. So base 36 is pretty much includes all numbers and all letters. Moving on, if we want to take a look at some colors, like say you have a color code but you don't know what it looks like, well, we can go ahead and do that. We can show color by an RGB value. So let's go ahead and take a look at this one. Magenta. So as you can see, it comes up with a window and it shows it, and then we just close the window and then we can continue on. Let's take a look at one more thing in computer science, which is the sorting algorithms. Let's do a quick sort and do a random list of 1 million elements. So 10,000, 100,000, 1 million, and do values from 0 to 10. And it will pretty much print out or display to the screen our sorted list. And once it's done with that, it will tell us how long it took to process, and also how long, well, not how long, but the big O notation of the specific algorithm. So let's go ahead and do that. So here we go, 1 million elements with a range of 0 to 10, sorted in under a second. And you can see the big O notation of it. Quicksort is line arithmetic in best and average cases, and the worst case, of course, is O of n squared. And if we want to see what values constants are, we can do value of pi. It tells us the value of pi. If we want to take a look at some temperature conversions in chemistry, we can do that as well. So let's do Celsius to Fahrenheit. Let's do 100 degrees Celsius, which should be 212 degrees Fahrenheit. There it is. So let's continue. Now I want to show you the standard calculator. So if you want to just evaluate some expressions, we can go ahead and do that. So 43 times 849 times math.e, and there we go. And if you want to take a look at all of the commands, you go ahead and type tree, and then as you can see, it shows all the commands. There's like 400 commands you can do, so you're not 400. I think it's like maybe like 120. 400 is the number of input options. I'm bad, so about 120 things you can do. So moving right along, just want to show you a little bit from the geometry section before I go. Alright, so if we want to convert, let's say we want to convert radians to degrees. Say we have math.pi 2 times math.pi radians, the circumference of a circle, and we want to convert that to degrees. We get 360 degrees. Let's do a little bit more in here. Sorry, I'm saying let's do Let's do the Pythagorean theorem. Let's find the hypotenuse. Let's do a Pythagorean triple, 3, 4, 5. There we go. We can do, let's see, what can we do? We can go ahead and take a look at the midpoint. Say we want to find a midpoint in n dimensions. We can go ahead and do that. Say we have a midpoint we need to calculate in 4D. We can do that. So first point in dimension 1, let's say 0. Second point, 0. So 0, 0, and then let's do 5, 5, 6, 6, 4, 4, and voila! It gives us the 4-dimensional midpoint. Moving right along, if we go ahead and let's test one last thing. Let's test a circle and the area of a circle with a radius of 5, so pi r squared. So 25 times pi will give you about 78. So that has been it for this video. I hope you guys enjoy the universal calculator, and there will be updates soon, so check in for those. There's a built-in auto updater, so it checks for updates, and that's all you have to do. You don't have to go back to the website. So hope you guys enjoyed this video, and I'll see you all again next time. Bye.